In this video, I'm going to do problems 1 to 3 of the problem bank. So for number 1, they just want to make sure that you know that work is equal to force times displacement. I don't particularly like this question because they should specify that he lifts the block at a constant speed and that when he walks horizontally, he is already walking and is moving at a constant speed as well. But for the purpose of this problem, you can assume that he is carrying the block at a constant speed. And so, your Gibbons mass is equal to 4.5 kilograms. The vertical displacement is 1.2 meters. And you don't need to worry about the horizontal displacement because there is no force in the x direction if he moves at a constant speed. And so, your unknown, obviously, is work. And the equation is work is equal to force times distance. You can ignore cosine theta for this part because you know that they are parallel. So, substitute. Work is equal to force, which is mg, which we should probably mention here. mg h, I guess. Force is equal to force of gravity, which is equal to mass times gravity. And so 4.5 kilograms times 9.8 meters per second squared times 1.2 meters is going to be equal to 52.92 joules, which is your answer. And next up, we have a similar problem, except it's about power. And again, I really don't like this question because it doesn't specify work from what force. So the net work in this problem is going to be 0, but they want you to find the work done by the constant force. However, they don't mention that in the question, which is neglectful of them. And so you're given the mass is equal to 15 kilograms. The force is a constant force of 73.5 newtons. The angle is 30 degrees, but we don't care about that because we are only worried about this force. And the displacement is 3 meters. And the time is 1 minute, which is 60 seconds. And so our unknown is we are trying to find power. Our working equation, power is equal to work over time, which is also equal to force times distance over time, and that is going to be our working equation. What's next? Solve, substitute. So power is equal to the force, which is 73.5 newtons, times the displacement, which is 3 meters, over time, which is 60 seconds. And that is going to bring you to 3.675 watts. So again, keep in mind this question is a pretty bad question. They want you to find the work done by the constant force. Right. So next up, we have number 3. It's a fairly lengthy problem, so I think it'd be best if we draw out a diagram. We have a crate, which is this badly drawn box right here. And it is pulled by a rope that is making an angle of 30 degrees with the horizontal. So, yeah, that should work. 30 degrees. the tension is 125 newtons, and the displacement is 5 meters. They want you to find the work done of these things, and I'm not going to write those down. So for part A, they want you to find the work done by the tension in the rope. If you remember what I said before, work is equal to force times distance, but only when force is in the direction of the displacement. So let's tack on our cosine theta there. And that will be sufficient for what we are doing here. So let's substitute. Work is going to be equal to 125 newtons times the displacement, 5 meters, times cosine theta, cosine of 30. And that gives us 541.3 joules. Next up, they want us to find the work done by the weight of the crate. So, if you look at this problem, or if we draw FBD, this is the force of tension, this is the normal force, and this is gravity. But our displacement is in this direction. So since the force of gravity is perpendicular to our direction, then that means that there is no work being done. So for the work from the crate, it's going to be 0. A. B is going to be 0 joules. And C, the normal force, that is pretty much the same. It's perpendicular. So it's going to be 0 joules. D, the force of friction, well, if we add that onto our diagram, our frictional force is going to be equal to the x component of our tension force, since if you do a net force equation, the net force in the x direction will be the x component of tension, which is T cosine 30 minus whatever's left, because it is at a constant speed, so the net force has to be 0. Frictional force, which is equal to 0. So you know that frictional force is equal to T cosine 30. It's just in the opposite direction of the x component of tension. So it'll be the same thing as A, except negative. Lastly, we're trying to find the net force. Well, since it is at a constant speed, the net force, the work done by the net force, is going to be 0, because the net force is 0, and so 0 times 3 is 0. 0 joules. And that'll be it for 1 to 3. If you have any other questions, like if I didn't explain it well enough, feel free to ask. I'm going to do the rest in the next 2 videos.